Good day, Nixers, and once again, welcome to this series about marine electricity and electrical maintenance. In the previous videos, we have discussed about power distribution system. Isa sa mga systems na diniscuss natin is the motor starters, or specifically, the main switchboard starters. And we have discussed that these starters are actually starters for our pumps, starters for our fans, which are actually run by using an electric motor. Now, in today's session, we will explore how to start these electric motors using different electric motor starting methodologies. Prior to that, we will be learning about the various components that are used for motor starting. So this will be our topic of interest, the AC motor starting methodologies. At the end of this lesson, the learner shall be able to identify and explain how each component of a motor starter works, specifically the push button switches, the contactor, the pilot lamps, and the timer relay. Okay? And then we will explain how a holding contact works. And lastly, we will explain the following starting methods for AC motors and its characteristics. And these are the direct online motor starter, the power resistance starting, compensator starting, and the star delta motor starting. So without further ado, let's start. To start our discussion about different electric motor starting methodologies, let us first use an analogy to put our discussion in context. Okay? And here we will see a video clip. Now question, okay? Saan ba tayo mas nahihirapan or mas nag-e-exert ng effort? Kapag ba nagsisimula pa lang tayong magpedal, okay, or nagsisimula pa lang tayong paandarin yung bisikleta, or kapag umaandar na yung ating bisikleta? Okay. Now I think we could all agree na it is during starting. Okay? Sa simula ng pagbibisikleta natin, mas nag-e-exert tayo ng more effort. Kung pagkaupo natin sa bisikleta is gandang-ganda or gwapong-gwapo tayo sa sarili natin, may mababawasan niya ng ilang porsyento pag nagsimula na tayong magpedal. So sa mga sandaling yan, nagsasalubong yung kilay natin, malabas yung mga kaugatan natin sa liig at malaki yung butas ng ating ilong. Lalo pat yung ginagamit nating bisikleta is kinalawang na dahil kung hindi pa nagka-pandemya is hindi natin gagamitin. Okay. Now, the bicycle starting is actually similar with motor starting. Okay? Kung sa simula is nag-e-exert tayo ng more effort para paandarin yung ating bisikleta, sa electric motor naman, okay, gumagamit tayo ng more current during starting. Okay? Keep this analogy in mind as we will be using this later on. Okay? Now, before I continue discussing why we need to learn the different electric motor starting methodologies, let me first pass, okay, or daanan muna natin yung pinaka-simple, okay, yung pinaka-simplest of all electric motor starting methodologies, which is what we call the direct online motor starter. Okay? Ano ba tong direct online motor starter at bakit ba natin siya kailangan daanan muna bago natin i-discuss yung mga kasunod na mga electric motor starting methodologies? Okay? Direct online motor starter is a kind of starter which is also known as a cross the line or full wave voltage starter. Meaning ng full wave voltage starter is kung ano yung na-generate ng ating generator na voltahe. Lahat ng yun or yung buong na-generate ng ating generator, yun yung isusupply natin, okay, sa ating electric motor. Full line voltage starter. It is designed to apply full line voltage to the motor upon starting. Now, there are two types of direct online motor starters. We have the manual and we have also the magnetic. Now, for the manual motor starters, ito yung kanyang forma. Okay? At ito yung schematic diagram ng ating manual starter. Basically, okay, we have the main contacts. Okay? This one, so normally open. Yung ibabaw is connected to the supply voltages, line 1, line 2, and line 3. This is the three-phase AC voltage. Okay? Konektado dyan sa ibabaw. Then sa ilalim, konektado yung ating overload heaters, okay, which disconnects or trips whenever there is an overcurrent. And then after that, konektado yung ating three-phase motor. Okay? Basically, pag pinindot natin yung start push button, okay, it will remain connected. So ito magko-close, close, close. Okay? So it will remain connected and then current will flow. Our supply voltages, line 1, line 2, line 3, papunta sa ating motor, enabling our motor to run. Okay? In cases of overcurrent, itong overload heaters natin will disconnect, okay? Will trip, and then so this allowing the flow of current from our supply voltage to the three-phase motor in order to protect our expensive na motor. So di bali nang mag-trip yung ating overload heaters, okay? Wag lang masira yung ating three-phase na motor. Okay? So, pindot natin yung start, so magla-latch. Okay? Pag pinindot natin yung stop, saka natin madi-disconnect. Okay? So, ito yung manual starter. Now, for the magnetic starters naman, so ito yung forma ng magnetic starter. So here, kikita natin na we actually use a contactor. So, yung kanina, is manual motor starter. This time, we are actually using a contactor. Mapapansin natin dito that we have two circuits. Itong nakakulay black sa ibabaw. Kung napapansin nyo to, kulay black. At itong nakacolor red, okay, dito sa ilalim. Now, we call the circuit sa ibabaw as the power circuit. Okay, ito yung circuit kung saan nakakonekta yung ating load. In this case, yung load natin, yung gusto nating paandarin is yung ating three-phase motor. Again, I'll emphasize that again, that the power circuit is the circuit where our load is connected. Okay? At ito naman dito, itong nakakulay pula, we call this circuit the control circuit. Meaning, we could manipulate, we could turn our load on or off depending on this particular arrangement on the control circuit. So, tingnan natin how does this magnetic starter functions. Okay, so basically, kaya siya tinawag na magnetic starter because gumagamit tayo dito ng electromagnetism, okay, in order to turn on our motor and remain, okay, hayaan natin na manatili itong nakaandar, okay, using magnetism. So, paano ginagawa ng circuit na ito yung ganitong function? So, let's observe, okay. So, here, we have this particular symbol. So we have the line voltages, line 1, line 2, line 3, same with the manual starter. We have this symbol. Itong symbol na to is actually the MCCB or molded case circuit breaker. Okay, so itong ganito na breakers is solely intended for high power applications. Okay? So sinasabi nga nito is it can withstand amperage levels of up to 2,500 amperes. So mas heavy duty kumbaga itong MCCB, unlike sa MCB or the miniature circuit breaker. Okay, so for motors, ito yung ginagamit natin, MCCB, molded case circuit breaker. So line terminals, then MCCB, then connected sa main contacts ng ating contactor. Okay, and then overload heaters, then to our motor, three-phase motor. So ito yung ating power circuit. And on our control circuit, meron tayong makikita dito na this symbol. This symbol is actually for the fuses. So I'm sure you're familiar with fuses, yung kapag nag-overcurrent or nag-overload sa bahay ninyo, okay, puputok yan, meaning nag-disconnect. Okay? Yung wire sa loob ng fuse is naputol. Okay? Yun lang yung disadvantage ng fuse. Kapag sumabog na ito or if there is overcurrent that happened, okay, on our circuit, so it is disposable. Okay, kailangan na nating itapon, bili tayo ng bago. So in order to do away with disposability, for example, wala tayong fuse na spare, okay? So mas maigi na reusable yung ating protection device. Kaya in cases na wala tayong fuse, mas maganda na itong MCB yung gamitin natin, okay, for our control circuit. fuse or MCB. Mapapansin natin dito, we have this symbol. So this symbol is actually for a transformer. So basically, ang function ng transformer is to step up the voltage or to step down. Patataasin niya yung voltahe or pwede din na pabababain niya yung voltahe. In the case of this particular control circuit from 575, okay, sa primary side, okay, naging 120 volts sa secondary side. So this is actually a step down transformer from 575 volts na supply, okay, to 120 volts on our control circuit. So this is a step down transformer. Then after that, dito sa control circuit, we have another fuse, a stop push button, normally closed, okay, then a start push button, normally open, then the coil of our contactor. Bakit natin nasabi na coil yan ng ating contactor? Because of the designation M. Kung mapapansin niyo dito, the main contacts is M. Okay? Designated as M. So meaning, itong mga contacts na to will depend whether this coil is energized or not. Whether there is current flowing through the coil or wala. Okay? And this is the overload auxiliary contact. Okay? So itong overload heaters natin, okay, once it trips, so may mangyayari din sa normally closed na contact na ito mag-o-open. Okay? And then we have this contact here. So on the previous video, na-discuss natin that whenever we connect a contact, auxiliary contact, normally open of a contactor, in parallel, a push button switch, this actually functions as a holding contact. Meaning, when we press this one, since push button is momentary, pag bitaw natin, pabalik siya pagiging normally open. Okay? So, this particular contact will provide another path. Okay? Isipin nyo na lang class na itong coil natin is claveria. Okay? Pwede kang dumaan from Ecolan, okay? Dadaan ka ng Sandawa. Sandawa, then Magallanes, then Claveria. Okay? Or, pwede din na from Ecolan, okay, sasakay ka ng bangkal na jeep, dadaan kayo doon sa bridge, okay? And then, dadaan ng boulevard hanggang sa makarating kayo sa Claveria. So, basically, it provides another path for the current to flow. Okay, so, pag-press natin ng start, energize M, okay, but pag bitaw natin sa start button, since ito mag-close, okay, so, yung kurente natin will pass through this alternative route. Okay? Making the coil M energized pa rin. At pag nag-energize ito, close, 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 line 1, line 2, line 3 will be supplied to our three-phase motor. Because of this holding contact, mananatiling umaandar yung ating motor. Okay? Now, the only way to stop the motor from running is when we press this normally closed push button. Okay, pag pinindot natin to, okay, there will be no flow of current through our coil. So magde-de-energize, this one will go back to its normal state, magiging open ulit, walang kuryente na mag-flow to our motor. Or, another way is, pag nag-overcurrent, okay, pag may overcurrent ating motor, okay, then this will trip, this will open. De-energize pa rin yung ating coil. Okay? Now, what's the difference, significant difference between a magnetic starter and the manual starter for direct line? Okay? So, kung napapansin nyo dito class, during blackout condition, kunwari, umaandar yung mga systems natin, and then suddenly, okay, nagkaroon ng problema. Okay? So, na-de-energize lahat ng circuit. But later on, biglang bumalik yung ating supply. Okay? For a manual starter, okay, as discussed previously, for the manual starter, the moment na bumalik yung kuryente, okay, kapag na-press natin itong start push button kanina, okay, so it will remain pressed. Meaning, pagbalik ng kuryente, manantili itong naka-latch, okay, naka-on, so automatic magpo-flow yung kuryente papunta ng ating motor. And as discussed previously, malaki yung kuryente during starting. And imagine class, pag hindi lang isang motor yung papaandarin natin, okay, maraming mga motor. Maraming mga motor, maraming matataas na kuryente during starting. So, basically, magkakaroon ng problema ating system. Either our generator, we will experience overcurrent o ganon pagbalik ng kuryente. And this is actually the reason why yung mga parents natin, madalas yung nanay natin is sinasabihan tayo na i-turn off yung ref during brownout, okay, ref, okay, i-turn off yung mga ilaw, lahat ng mga appliances, tanggalin sa saksakan. Okay? It's because maaari na narinig nila yung balita na nung bumalik yung kuryente, okay, sumabog yung fuse or nag-trip yung breaker. It's because of this particular loads na mga motor, okay? Yung mga motors like refrigerator, aircon, okay? Pag yan bumalik yung kuryente tapos yung mga loads na yan, okay, is naka-turn on, okay, automatic diretso isusupply yung kuryente, there's a possibility of an overcurrent. Kaya yun yung mga based on experience na minsan hindi natin alam uh, bakit kailangan namin gawin ito. Okay? Minsan hindi nila ma-explain but actually the reason behind that is because during starting, okay, these induction loads, okay, yung mga motors natin, compressors, are actually having high, okay, starting currents. Okay? That is why it results to an overload. Yun nga, magte-trip yung breaker or sabog yung fuse. But for a magnetic starter, mapapansin mo dito, kapag nagkaroon ng blackout, tapos bumalik yung kuryente, pag nagka-blackout, de-energize itong circuit. Okay, so yung start push button, baka normally open. Ito naman, since de-energize, ito will be open. Okay? So meaning, pag bumalik yung kuryente, wala tayong choice, kundi pindutin ulit yung start push button para umandar yung motor. Unlike doon sa manual starter na naka-latch. Basically, pwede nating dahan-dahanin, okay, napaandarin yung bawat motor natin sa electrical network. Pwede ito muna, press the start push button, umaandar na. O, okay, mataas na kuryente pero sa isang motor lang. Next, ito na naman, press the start push button, then itong motor na naman na ito yung aandar. Like doon sa manual starter na pagbalik ng kuryente, sabay-sabay. Okay? Sabay-sabay sila mangangailangan ng mataas na kuryente and it will be detrimental to the power supply of the electrical network. Kaya kung magnetic at manual starter ang pag-uusapan, with regards to this particular aspect, mas preferred si magnetic starter. Okay? So nabanggit natin kanina na kailangan muna natin daanan ang direct online motor starter bago natin i-discuss yung ibang electric motor starting methodologies. So bakit? Okay? Basically, itong direct online motor starter, although it is the simplest of all mga electric motor starting methodologies, okay, it can only be used for small rated motors. Okay, yung mababa lang na rating na motor, yung mga maliliit lang na motor. Typically less than 5 horsepower. Okay? O example nga nito is a squirrel cage induction motor. Now bakit? Okay, now bakit kailangan or bakit ba yung direct online for small motors lang? Okay? Una, motors take its three-phase AC power from the generators via the bus bar. So, kung naalala ninyo on our discussion on power distribution systems, yung main switchboard starters natin is actually taking its power from the main bus bar 1. Okay? So meaning, every time that a motor is turned on, okay, voltage supplied by the generator dips or becomes less. Every time na may aandar na motor dyan, yung voltage na sinusupply ni generator is biglang bababa. Pero babalik ulit sa dati. So bakit biglang bababa? It is because, okay, when a motor is turned on or any load for that matter, pag meron tayong pinaandar na load, okay, yung speed ng ating generator will actually decrease. Then, after that, since nag-decrease yung ating speed, kailangan ibalik ito sa rated speed. That is the function of our governor generator. I-control niya yung supply ng fuel in such a way na babalik sa rated speed yung ating generator. Pag kabalik niya sa rated speed, babalik din siya sa rated voltage. Now, this is the reason why direct online is only applicable for motors that are small rated. Yung mababa lang yung rating. It's because for larger motors, mas mangangailangan na ng high starting current. And actually, in technical terms, we call these currents inrush currents. Yung starting current na binabanggit natin kanina is inrush currents. These currents are actually typically high in value, 6 to 8 times that of the running current. Kung kanina sinasabi natin na during starting, mag-e-exert tayo ng more effort para paandarin yung bisikleta kaysa sa pag umaandar na ito. So in this case, inrush current, 6 to 8 times more yung kuryente during starting compared sa kung umaandar na yung ating large motor o high inrush currents. Because of that, it becomes a problem for motors rated at greater than 5 horsepower. Problema yung full line voltage starter kapag in-apply natin siya sa motors that are greater than 5 horsepower. Now, bakit? Large motors have large diameter wires. Meaning, pag mas malaki yung motor natin, mas malaki yung wire na gagamitin natin for the stator coils and the rotor coils. Now, pag mas malaki yung wires na ginamit natin, mas mabigat yung rotor. Pag mas mabigat yung rotor, binabanggit natin dito more inertia. Inertia meaning the tendency ng isang bagay na hindi gumalaw. So, ano yan, given yan, na pag mabigat, sample, tulak natin yung mabigat na tao, mahihirapan tayo. Compared kung payat yan, matutulak natin yan. Meaning, it will take time for our motor to reach its full load speed. And because of that, because of this longer time to reach full load speed, there will actually be longer time na expose yung ating motor windings to high inrush currents. Since yung mga coils natin have resistances at may current na dumadaan sa kanya, then it will incur power losses. And we all know that power is the square of the current times the resistance. P is equal to I squared R. Malaki yung kuryente, in-square pa natin times the resistance. So this power dissipation will actually dissipated as heat, init. And itong init na ito will actually contribute the wear and tear of our large electric motor. Meaning, mas mapapaikli yung lifespan ng ating motor kapag full line voltage yung gagamitin natin. So again, large motors, mas malalaki yung wires na ginamit. Mas malalaki yung wires, mas magiging mabigat. Magiging mabigat, more inertia. Mahirapan tayong pagalawin. And because of that, mahirapan tayong pagalawin, it will take time for it to reach full load speed. Pag longer time to reach full load speed, mas expose yung ating coils or yung ating mga wires sa loob ng motor to high inrush currents. Because coils have resistances, it will incur power losses. So may kuryente na dumadaan sa coil, square niyan times the resistance of the coil, yun yung power losses dissipated as heat. At yung heat na yun yung sisira. So killing me softly yung nangyayari dito ating electric motor. So this is the reason why kailangan natin ng hindi lang direct online na electric motor starting methodology. Kailangan natin ng iba pa. Now another result of an inrush current is actually a voltage dip or sag. So again, nabanggit natin na itong mga motors natin is actually connected to our bus bar at yung bus bar natin, yung supply na dumadaan dyan is from the generator. This means that whatever is the voltage applied on that bus bar will actually be the voltage supplied to our electric motors. In other words, our electric motors are connected in parallel since voltages in parallel are actually equal. Now, any voltage fluctuation, meaning pagtaas o pagbaba, in this case, since voltage dip, pagbaba, any voltage dip, okay, will actually affect our electric motor's torque. Okay? What is this torque? Torque is a parameter related sa pag-ikot ng ating motor. Okay? This particular torque equation for three-phase induction motors, okay, makikita natin dito that torque is directly proportional to the square of the rotor voltage. So, related ang torque sa square ating voltahe. Okay, meaning, pag nag-fluctuate yung ating voltahe, okay, bumaba, maapektuhan din, bababa din yung ating torque. Okay? And because of that, okay, pag bumaba yung voltahe, maapektuhan yung torque, it will actually can cause the stalling of motor. Stalling meaning it will actually cause our motors to stop running. Because nag-stop ng pag-run yung ating motor from a running condition to a stop condition, it will actually result to belt, chain, and even coupling breakage. So, nabanggit natin yung parameter na torque kanina. So, ano ba yung ibig sabihin ng torque? Okay, let's discuss this further in relation to motors. Okay? Now, another reason why we employ electric motor starting methodologies is because okay, there are two types of torque that are related to motor. Isa is para mapaandar natin ating motor, which is known as the starting torque. Yung pangalawa naman is para manatiling umaandar yung ating motor or the running torque. So, typically, yung starting torque ng mga large electric motors is actually 25 to 64 times that of the running torque. Meaning, pag umaandar na yung ating motor, 25 to 64 times of that will be the torque needed in order to start our. Because of this very high torque, the starting of the electric motor, it can actually result to shaft damage. Yung interconnection between the motor and the load, okay, will actually be damaged. Okay? So these are the reasons why kailangan natin ng other electric motor starting methodologies aside from the full line voltage starters. Sa summary, okay, small motors will actually be applicable yung full voltage starting method. Okay, yung ating direct online motor start. But for large motors, there are actually two problems. Una is the presence of high inrush currents. Yung pangalawa is the high starting torque. This can only be resolved through the application of reduced voltage starting mas mababa na voltage na motor starting methodology. Sa full line voltage is binubuhos natin yung buong okay, na-generate na voltahe ng ating mga generators. This time, okay, we will find a way na mapababa yung voltahe na isusupply natin sa motor the beginning stage para hindi ganun kataas yung ating kuryente. Hindi ganun kataas yung ating kuryente, hindi ganun kataas yung ating torque. Okay? Now, what are these types of reduced voltage starting methodology? Okay, so we have three. Una is the primary resistance starter. Second is the compensator starter. The third is the Y delta starter. Now, for the primary resistance starter, okay, the primary resistance starting involves connecting a resistor in series with the stator coils of our electric motor. Okay? During starting, kukonektahan natin ng resistor yung ating stator coils. During starting lang. Okay? Now, typical applications of this particular starting methodology is for conveyors, okay, belt-driven equipment, and gear-driven equipment. Now, how does primary resistance starting work? Or bakit ba siya tinawag reduced voltage starter? Okay, now to be able to explain that, let's go back to a lesson in Electro 1, which is on series circuits. Okay? Now, we will be simulating. So here we have a circuit, okay, which has a 120 volts, 60 hertz supply. And then we have two resistors that are connected in series. Okay? So never mind this particular switch muna. Okay? So in this case, okay, we have the supply, the resistor, and then two resistors. Yung isa 2 kilo ohms, yung isa naman 1 kilo ohm. Okay? Now what if we interconnect or we measure the voltages across each of these resistances? Okay? Meron tayong nito yung ating multimeter or multitester. Okay? This one, bit natin siya dito sa 2K now. As what we have learned in Electro 1, to be able to measure voltages, kailangan i-connect natin yung multitester in parallel, okay, with our load. Okay, kung ano yung i-measure natin. Same thing with the second resistor. Bit natin dito. And then dito. So let's simulate. Okay, play natin. Run natin yung simulation. Tingnan natin ano yung voltahe na mame-measure natin sa 2 kilo ohm na resistor. Okay? We have voltage. Okay? Measure natin since this is AC. So lipat natin sa AC. In this case, yung mame-measure natin sa 2 kilo ohm is actually 80 volts. Okay? Now, what about the second multitester? Ano yung mame-measure natin sa 1 kilo ohm? Okay? Again, this is DC. So lipat tayo sa AC. Voltage. Dito naman is 40 volts. Okay? Kung napansin natin class, 120 yung supply natin. Okay? Dito nag-drop 80. Dito naman nag-drop is 40. Okay? Meaning the sum of the voltage, 80 plus 40 is our supply na 120 volts. Okay? Now, what if, okay, since ito 1K, ito 2K, what if ang gagawin natin, okay, we'll stop the simulation, ang gagawin natin is gawin natin tong 1K. Okay? Gawin natin tong 1 kilo ohm. What will happen to the voltage drop? Okay? Let's play the simulation. Yan. So, mapapansin natin that if this is 1K, this is also 1K, 60 at saka 60 volts yung mame-measure natin sa bawat resistances. Okay? Meaning, nahati yung voltahe. Okay? This is actually a voltage divider configuration, meaning hinahati natin yung voltahe proportionally depending on the value ng resistance. Kanina, 2K ito, kaya mas malaki yung na-measure natin dito, 80, compare dito sa baba, 40 lang. Ngayon, since pareho sila, then 60 at saka 60. Okay? So, what if naman, okay, in this case, kita nyo tong switch na ito, what if i-turn on natin itong switch na ito? So, this time, it's open. Normally, open yung switch. What if i-close natin yan? Anong mangyayari sa voltahe na ma-measure natin sa resistance na to, sa R1? Okay, so let's try to observe. Play natin. Okay, so currently 60 at saka 60 when we close this switch. Okay, yan. In this case, yung na-measure natin dito is 12 microvolts or very close to zero na yan. So let's say 0 volts, 0 volt dito. Dito naman concentrated yung 120 volts natin. Meaning in this case, lahat ng voltahe na sinupply natin nandito na sa resistor na ito. Wala nang dumaan sa R1. Okay? Because currents pass through the path of this resistance. Since ito walang resistance, zero, since this is a wire, okay? Kaya naman, zero, so dito dumaan yung kuryente natin. Binaypass na niya itong 1 kilo ohm. So this is very important for primary resistance starting, as we will see later. Okay? Let's go back to our slide presentation. So moving on, ito yung forma ng primary resistance starting. Okay? Mapapansin natin dito, we still have the line voltages. Okay? We still have this, okay, main contactor or the main contacts of our contactor. Then here, we see the resistor bank. Okay? Resistors that are connected in series with the windings of our three-phase motor, the stator coils. Okay? Itong resistance na to nakaseries sa mga windings sa loob ng, okay, motor natin. So in this case, okay, just like on the simulation kanina na may dalawang resistances, so yung supply natin dito will be divided. May madadrop sa resistor, okay, Then may madadrop din dun sa windings. At yung madadrop sa windings, yun lang yung magpapaandar sa ating motor. That is why this is called reduced voltage starter. Okay? So during starting, mababa yung voltahe na i-apply natin sa windings ng motor. Okay? Para dahan-dahan. Mas mababa ang voltahe, mas mababa na kuryente, mas mababa na torque. Okay? Pero pag na-reach na niya yung kanyang running, okay, running speed, saka natin ito turn on. Okay? Saka natin iba-bypass itong resistors. Just like yung switch kanina. This will close, close, close. Instead na dumaan dito sa resistor, okay, babypass natin because current will pass through the path of least resistance. Yung full voltage na ngayon, yung magpapaandar sa ating motor. Okay? So, ginagamit lang natin yung reduced na voltage during sa starting. Pag umandar na, okay, steady na, full load speed na, then that's the time lipat tayo sa, okay, running contactor. In this case, kung titingnan naman natin yung control circuit, ito yung power circuit natin, ito yung control circuit. We still have a transformer. Okay? Then we still have a fuse. Stop. So, pag in-start natin, pinrest natin yung start, energize si coil na M. Okay? Pag na-energize si coil na M, yung holding contact, magko-close. At the same time, itong mga contacts dito, close, close, close. Okay? Pag nag-close yan, then current will flow dito. So, hindi siya dadaan dito since open. Okay? So, dito siya dadaan punta sa ating motor. Okay? So, reduced voltage yan. Pero, at the same time, dito sa control circuit, pag nag-close ito, the timer relay. Okay? This is an on-delay timer. Okay? After a certain time, okay, so pag-close nito, magka-count 1, 2, 3, depending on the set timer, set number of seconds na sinet natin sa timer relay, okay, saka palang magko-close itong timer relay na normally open contact. Pag na-energize yan, after certain seconds, magko-close, si run contactor will be closed also. Okay? Pag nag-close si run contactor, or nag-energize si run contactor coil, okay, this one will close, close, close. Babypass niya na ngayon itong resistances. So, hindi na siya dadaan dito, dito na siya dadaan. And full load voltage will now be applied to our three-phase motor, okay, during full load. Okay? Full load speed. Yan yung function ng primary resistance starting. Okay? Kung sa direct online motor starter, gumamit lang tayo ng isang contactor. In our primary resistance starting, gumamit tayo ng dalawang contactor, the contactor M, okay, at yung contactor na R, the run contactor. At the same time here, gumamit tayo ng timer relay along with the other, okay, control devices na na-discuss na natin kanina.